So last class we were discussing the concepts from magnetic effects of current. Right? There is one last topic that is left out, that is electromagnetic induction. Right. So after electromagnetic induction, we can start the next chapter, that is light. Okay. So before we proceed, can someone tell me what exactly does electromagnetic induction mean? What is this all about? Anybody? Are you guys able to hear me? One minute. One minute. Yeah, now tell me, are you guys able to hear me?
Yes, sir.
Okay, now it is better. Yeah, can someone tell me what does electromagnetic induction mean? Are you hearing my voice twice?
Yes, sir, we can hear you.
Okay.
Sir, to induce current with the help of magnetic field.
I am actually logged in through two devices.
So your voice is echoing, sir.
Yeah.
Yes, sir.
That's
Yes, sir.
because of two devices. Now someone speak.
Now, sir?
Yeah, now it is. Yeah. Yes, we'll get started. So tell me, guys, what does electromagnetic induction mean?
It's production of electric current in a circuit with the help of a moving magnet, inducing current.
Okay. So what is the meaning of induction? That's perfect answer. So what is the meaning of induction?
Inducing, adding.
So inducing. So it is like generating something. Okay, I'm not talking about electromagnetism here. Generating something without any physical contact. Okay, generally, that is what we call it as induction. Okay. Then electro here refers to electricity. You can say it like this. Okay. And magnetic obviously refers to magnetism. So till the topics that we discussed before this, what was our main concept of discussion? We were concentrating on when electric current is flowing through the circuit, what kind of magnetism is generated. But here we are exactly using the reverse principle of it. So reverse principle means how can you make use of the magnetism to generate electric current? Okay, so that's what the whole concept is. Okay, now the question is, how are we going to generate it? How exactly do we do that?
By changing the direction of the magnetic field, or like the strength of the magnetic field.
Changing the strength of a magnetic field through what?
Not strength, but like moving the magnet
Changing the speed.
top of the electric circuit.
Electric circuit. Should that circuit be closed or open?
Closed.
It should be closed. Okay. I have a question. So if I take a wire like this, okay, I'm taking a metallic wire and I'm taking a magnet. Okay. I am trying to move this magnet. Will there be any electric current generated in this wire?
Changing the
No.
Answer is no. Okay. Then how is it supposed to be?
It should be connected to cells It should be in a closed circuit.
Okay. So now I have a question. You told it should be connected to a cell, right? If it is already connected to a cell, okay. If it is already connected to a cell, the current is going to flow through it, irrespective of whether you have a magnet or not. But we are saying electromagnetic induction is something where you need to generate electricity only using magnetism. You should not use any external source. You should not use any active element. That is, you should not use a battery, right? Are you guys able to understand?
Yeah.
So what are we supposed to do? So we need to have, it's not a circuit, don't use the word circuit, okay? You need to have a coil.
Primary coil.
You need to, no need of primary or secondary coil. You just need to have a coil or a single loop. So what is the difference between a loop and a coil is, if there is only one winding, okay, if I take a wire and I just bend it in the form of a circle, then that is called as a loop. I call it as a circular loop. If the same loop has multiple windings, we call it as a coil. Okay. So if you have a loop or a coil in which you are able to change the number of electric field lines, okay, I'm repeating it again. If you are able to change the number of electric field lines, then it is observed that the electrons inside those metallic conductors will start moving. And that phenomenon is something which you can observe. And that phenomenon where you are able to induce electricity using magnetism is what is called as electromagnetic induction or EMI. In simple terms, we call it as EMI. Guys, are you able to understand? Am I clear?
Yes.
Yes.
Okay. Now, I just want to show you a small simulation so that you're able to visualize what exactly is happening. Okay. Just a minute.
So I can't hear you.
So we cannot hear you, sir.
Okay.
So you're not audible, sir.
So now am I audible?
Yeah, yes, sir. Yes, sir.
Yes, sir.
And are you able to see the screen also?
Yes, sir.
Yes.
Okay. Now see, you have a coil, okay? And the coil is connected to some device like this. What is this device? It's there in your textbook also actually.
The galvanometer.
Galvanometer. So what does a galvanometer do?
Measures the presence
To
of
measure current.
If it is measuring current, then what does
Sensitive
ammeter?
current.
It detects the presence of
Galvanometer
current.
will
detects the
measure
presence of
It
It
only
measures sensitive current.
it only shows the presence of current. Okay, galvanometer is a device which shows the presence of current. Okay, now I have a coil, I have a magnet in my hand. Look at the way I'm going to move it. I'm moving it close, and look at the galvanometer. No? What happened to it? The galvanometer
There's a
it
deflect.
started deflecting to the left. That is, when the north pole was taken close to the magnet, what happened? It got deflected to the left. If I take the same magnet away from the galvanometer, see what is going to happen. Which direction did it get deflected? I'll do it again. It's a spontaneous, it's a very fast process, observe it. When I moved it close, it moved to the left. When I moved the same north pole away, it moved to the right. So what exactly is happening? Let's look at the way the electrons are moving. Okay, now I'm switching on. You will be able to see blue color dots. You're able to see these blue color dots.
Yes, sir.
Yes, sir.
When I move this north pole close to this, look at the way electrons are moving. They are moving in the downward direction. When I move the electrons away from it, it is moving in the upward direction. Aren't you able to see the change in polarities? That is the change in direction that is happening. Right? Now comes another question. So I am clear with two things, guys. One is I need a coil. By now you would have understood what a coil means. A coil which is not connected to an active source. What do I mean by active source? It should not be connected to a battery. Right? It is then the electrons are going to move using magnetism. Okay. And secondly, when I move the north pole close, if the electrons are moving in a particular direction, then if I move the same north pole away from it, then the same electrons will start moving in the opposite direction. That is another observation, right? If that is the case, then what is the name of this coil? This is the coil which is picking up the magnetism, right? This is what is called as the pickup coil. You are able to see here, PICKUP coil. It is called as a pickup coil. Now I have another question. Is it always necessary that I have only a magnet in my hand?
No, sir.
Okay,
No, sir.
I'll put the question. Is it necessary that I always have a permanent magnet in my hand?
No, sir.
So what else can I have?
Sir, electromagnet.
I can think of having an electromagnet also. So when I say electromagnet, this should be replaced by whom? This bar
Cross
magnet.
line.
It should be replaced with a closed circuit where that particular conductor is connected to a battery. Right? So are you able to understand? So that is what is called as electromagnetic induction. This was first observed by a scientist named as Faraday, Michael Faraday. Okay, he has given some laws and all those things. Those are not needed for you. But I just wanted you to visualize what exactly is electromagnetic induction. Are you guys clear? I know you know the concepts, but I just wanted to put it in a different way. That's it. Are you guys clear?
Yes, sir.
Yes, sir.
Okay. So this is electromagnetic induction. And what is the other concept that you have in your syllabus? What else did you learn in within electromagnetic induction? First is you would have understood what is an electromagnetic induction. Second is what is the type of electromagnetic induction that is there? Now I have a question. If I replace this magnet, this permanent magnet with an electromagnet, and I'm able to see the induction taking place, then what is the name of that magnetism? Sorry, what is the name of that induction?
Electromagnetic.
No, that is electromagnetic induction. It has another name. It's called mutual induction. Have you heard this term?
No, sir.
No? No problem. I'll show that also. See. So I'm replacing, I have a, so tell me which is a pickup coil, the right one or the left one?
The right one.
The right one is a pickup coil and the left one is what? It is connected to a battery. So once I start switching on, look at the way the electrons are moving. Now I will keep moving this. See, look at the screen. It doesn't have any field. As I keep increasing the polarity in the battery, look at the way the electrons are going to move in the conductor, the electromagnet, as well as the pickup coil. Look at them, no? You're able to see some spark. The bulb is glowing. Right?
Yes, sir.
Now see. Just, is it glowing? Okay, I moved it slowly. The effect is a little less, but see, I'll make the direct current flow. Is something happening?
So the galvanometer is blocking the bulb, sir.
So the galvanometer, no, it's not blocking the bulb, it is replaced. You can see, galvanometer is a sensor, bulb is also a sensor. Why are you using a bulb? To say whether current is flowing or not. It's a testing piece, right? So something similar. I replaced it. I can use this also. See. Now see, the bulb will glow. You're able to understand? So the intensity is increasing and decreasing. Guys, are you able to understand this particular thing? So One important point I wanted to mention here is you people told that the magnet should move, right? Write down this statement. Write down so that you understand it. When can electromagnetic induction be generated? First, when there is, please write it down. When there is a relative motion, when there is a relative motion existing between the magnet and the coil. When there is a relative motion existing between the magnet and the coil, comma, electromagnetic induction is observed. Okay. So what do I mean by relative motion? Can someone tell me? What do I mean by relative motion? So we have a misconception saying that only the magnet should be moved and the pickup coil is kept stationary, but I can do the reverse also. See, you're able to observe galvanometer shows deflection. The bulb is a better option for this. So magnet is stationary, but the pickup coil is moved. Guys, are you able to understand this point?
Yes, sir.
Yes.
Yes,
So
sir.
that is what is meant by relative motion. Relative means one of them can be moved at a time, or both can be moved at a time. If I move the magnet, if I move this also, then also I can observe that there is a current generated in this. That is the main principle which is used in a generator. But generator is not there in your syllabus, so let's forget about it. Okay. Okay, this is what I wanted to show, guys. I hope you're clear.
Yes, sir. Clear.
Yes, sir.
Yes.
Yes, sir.
I'm stopping the screen share. Yeah. So this is what the experiment says. You have a magnet, you have a coil. When the magnet is moved towards a coil, it sets up a current in the coil circuit as indicated by the deflection in the galvanometer. So if people know what a galvanometer is an instrument that can detect the presence of current. It is a sensitive device actually. Okay. It is a very sensitive device where even few microamperes of current are flowing through it, it can detect. It will start showing a deflection. So what is the difference between a galvanometer and ammeter is, if at all there is a practical based question that is asked, if I give you a device like this where the pointer is in this way, and if I give you a device like this where the pointer is somewhere over here, it is like this. Okay. So this also has something to do with current. This also has something to do with current. In the sense, I want you to identify which is a galvanometer and which is an ammeter. So
The
what is it going
first
to be?
the galvanometer and the second
So
the
first one
down
is
the
the first one
ammeter.
is the, yes, that's right. So if at all there is a practical based question, you should know this. I hope you guys would have seen it, right? The lab. Did you see?
Yes, sir. Yes.
Okay, that's good. So galvanometer will only sense, whereas ammeter will measure the value of current. So wherever the pointer goes and stops, that value is the amount of current that is flowing through the circuit. Whereas if the galvanometer is stopping like this, it doesn't mean that there is a current flowing. It is just to show the alternating values. Okay. So the pointer remains at 0. That is the center of the scale. This is a very important point. For 0 current flowing through it, it can detect either to deflect either to the left or the right of the 0 mark depending on the direction of current. So as I told you, Michael Faraday was the person to observe the electromagnetic induction. Okay, there are certain laws and all those things you will learn in your 12th standard. You need not worry about it. Okay. Similarly, if there is an electromagnet and if there is a pickup coil, still you can observe that there is a deflection in the galvanometer. Means the current is going to get induced. So generally, this type of induction is called as mutual induction. If you know the term, that is more than sufficient. Okay, it is called as mutual induction. So an important point is mutual induction is for your knowledge again. In your 10th standard exam, if they ask, you just use the word electromagnetic induction. Don't use anything else. Don't use the word mutual. So mutual means you will have two coils. That is the meaning. That is the meaning. But still the principle is electromagnetic induction only. I hope there is no confusion, right?
No confusion, sir.
Okay, good. That's good. So how do you find the direction of the induced current? So how do you find that what is the direction in which the electrons are actually, that is, what is the direction in which the induced current flows? So you use Fleming's right hand rule. So what is Fleming's? Yeah. So what does Fleming's right hand rule state? It's something similar to the left hand rule, Fleming's left hand rule, right? So in the right hand, you're going to stretch the thumb, the forefinger, and the central finger mutually perpendicular to each other in such a way that the thumb shows you the direction of what?
Magnetic field. Sorry,
No,
sorry.
no.
The
Motion,
current.
the
Movement of the
motion
convex.
it is a motion of the conductor. Okay. So
The
it is the
whole-
motion of the conductor that is being, so M, remember, movement of the conductor. Similarly, forefinger, obviously it represents field, and central finger represents the direction of the induced current. Okay. So this is the outline, guys. So when they ask you explain different ways to induce current in a coil, what are all the things? You can either move a magnet around a coil. You need not use the word pickup coil and all. Pickup coil is the technical name. Whatever is there in NCERT, just follow that. So when the magnet is moved towards a coil, then what can be observed? Then there is a current that is induced in this coil. That is one way. Or the other way is this thing, using an electromagnet and a pickup coil. Clear, guys? So these are all the different ways in which you can induce current. So the device which works on the principle, see, maybe you can know this word alone. What is the device that works on the principle of electromagnetic induction? The answer is electric generator. Okay, electric generator works on the principle of electromagnetic induction. If this comes as a 1 mark, you can just write that word. Okay, so with this, we are done with this chapter. Apart from this, do you have any questions?
Sir, where is AC battery used, sir?
In our house. In our house, it is alternating current. Okay. It is 230 volt AC and 50 hertz. Hertz means frequency. That is where we use it.
Okay, sir.
Okay. Any other doubt, guys? So I hope you're clear with finding all the directions and all those things, right? So that is where I see many of them having confusion. You know how to use Fleming's left-hand rule, right-hand thumb rule, Fleming's right-hand rule, all those things, right? If you give me
Yes,
the confidence, I'll move on to the next chapter.
Yes, sir. Very well.
Okay, that's good. So shall I move on? Now listen.
Yes, sir.
We'll get started with light. Okay. So what do you guys know? What are we going to learn in this chapter? So the topic itself says light. We are going to see two principles, that is reflection and refraction. Okay. So before that, what is light?
Sir, it's a form of energy.
Form of energy.
Okay, it's a form of energy. Okay, I'll just tell you a name, have it in your mind. Light is an electromagnetic wave. Okay, so when I say about light here, I'm trying to, in this chapter, we are reading mainly about the visible light. So this is what we are going to learn. So visible light is an electromagnetic wave. If you know that, that's more than sufficient. Nothing else outside that. So what is the speed of it? So what is the speed of light?
3 into 10 power 8.
10 to the power.
3 into 10 power 8 meter per second or 3 into 10 power 10 centimeter per second. My question is actually incomplete. Speed of light
In
What
a
should I-
vacuum.
In vacuum.
in vacuum or
Air.
air medium? I should have put this question because when we come to the concept of refraction, what is more important? We are going to discuss about the medium in which the light is going to move, right? So that's where we need to be careful. So speed of light in vacuum or air is going to be 3 into 10 power 8 meters per second. And that is the maximum value that is possible. Beyond that, no object can move. Okay. Now comes certain phenomenon exhibited by light. So what do you mean by phenomenon? I just told you, right? So phenomenon in science means something that you can see. So what can you observe with respect to a light? One of the important features is reflection. The other important feature is refraction. The question is about when is light going to reflect or when is light going to refract is what we need to answer. So tell me guys, when is light going to reflect?
When it falls on a
So
more
when it falls on a highly polished surface, right? When it falls on a highly polished surface such as a mirror, it starts reflecting. So most of the light falling on it. Okay. Now the question is, if at all this is happening, does it have anything like laws? What are all the laws that are associated with reflection of light? Anybody?
angle
So
of
if it-
incidence.
Angle of
Angle
incidence is
equal to
equal
angle
to
R
angle of
and incident
reflection.
normal.
Angle of incidence is equal to angle of reflection. Accepted. Next.
The incident ray,
Incident ray,
normal,
the
and
reflected
the
ray, and the
reflected ray
Incident
should be
ray,
same
reflected ray, and normal all lie in the
are
same.
on the same plane.
Same plane.
What do you mean by same plane?
The face of the
Sorry, can you repeat it? I didn't get you.
face of the mirror.
Face of the okay, I
If
can
they
take it.
present this on a Cartesian plane, then they all lie in the same plane. Like
That's right. Means if the incident ray is restricted to XY plane, then the reflected light will also be restricted to XY plane, and the normal will also be in the XY plane. Very good. Good that you use the word Cartesian. Okay. The incident ray. Okay, that is over. Now, first of all, what does angle of incidence mean? So all basic questions, guys. Make it fast. No? What is angle of incidence? The angle between the incident ray and
normal
the
and
the normal.
Okay, angle between the reflected ray and the normal is what we call it as angle of
Angle of
reflection.
reflection.
So IR is equal to I. Why it is so, we need not worry about it. That will be proved in your 12th standard again. There is a proof for it, but you need not worry about it. Okay. Now the next question is when I talk about a mirror. Okay, when I use the word mirror, the first thing that comes to my mind is mirrors can only reflect, right? So if that is the case, then what are the types of mirrors that are possible? I can think of a plane mirror, or I can think of curved mirrors, where the curved mirrors are subclassified into, sorry,
Concave
gas-
and convex.
Convex and concave.
concave and convex. So what do you mean by concave?
It's a curved inwards.
So it is curved inwards and it is polished outwards. Okay. Convex is
Curved
polished out,
outwards and
Curved
curved
out.
outwards. Okay. That is accepted. Okay. Now comes the question. Next question. If I talk about a plane mirror, okay, what are all the types of images that you know?
Real image and virtual image.
Real image,
Okay.
virtual image.
So, with respect to a mirror, what do you mean by real image? Which side is the image supposed to be formed for it to be called as real? With respect to a mirror,
the back side of the mirror.
is it on the same side as the polished surface or on the other?
It's the same side.
If it is falling on the same side of the polished surface, we call it as a real image. If it is falling on the other side, we call it as virtual image. Now comes another question. If I ask you about a plane mirror, does it form a real image or a virtual image?
Virtual image.
Virtual image. How? Okay. So, how are we going to actually show that it is going to form the virtual image? If suppose I have a plane mirror, okay, then I have an object like this, which is of an object AB, which is placed like this. If I ask you to complete the ray diagram for it, who can tell me how to draw the ray diagram? So what do we mean by ray diagram?
Since this,
Sorry, voice is breaking.
the image will be formed
voice-
from equal distance behind the mirror.
Okay. Okay. That's. Are you saying it theoretically, or you can prove it using a ray diagram? How do you know that that is where it is going to be formed? Where did you read it?
In the textbook.
It is there just like that, right? But did you ask the question of why it is so? And the answer lies in the laws of reflection. So how are we going to apply the laws of reflection? That's what we need to think of. There are only two simple rules. Even the second rule is not important. What does the rule tell us? Angle of incidence is equal to angle of reflection. So if I need to define the angle of incidence, what is that I need to define first? See, most of them miss this, okay? I'm just giving you the perspectives to think. So please concentrate. If I need to draw a ray diagram, most of them actually miss to draw an important line, which actually doesn't exist. Out of the incident ray, reflected ray, and the normal, what is the most important line, do you think? See, I'll put all the points. You guys know, listen to it carefully. If I need to define the angle of incidence, then what is the most important line that I need to draw?
Normal, sir.
It is the normal. Most of them forget. Okay. Second. So normal means I can draw normal to the mirror anywhere. I should draw it exactly at the point of incidence. That is first point. Second. How many rays do I need, or how many are the minimum number of rays required to complete a ray diagram to trace the location of the image? Minimum is 2. Maximum can be anything. Right. So minimum is 2. Let's use these two logics. You people already know this. Let's use the same logic to try to draw now. Let's think of it. Now, from point B, if I take a ray which is incident on the surface, okay. So what is this point called as? This is the point of incidence. So at this point of incidence, what am I supposed to do?
The normal.
I should have actually drawn a normal. Now, if I see this normal should be in your mind. I'm drawing it here so that you're able to visualize it, but that should be in your mind. Now, with respect to the normal, what is the angle of incidence?
90 degrees means
Common
perpendicular.
mistake. It is a common mistake. I know you'll tell this answer. It is 90 degrees with respect to the mirror. But what is angle of incidence? It is
0 degree.
It is 0 degrees. Right. So when the angle of incidence is 0, according to the laws of reflection, what should have happened to the angle of reflection?
Plus 0.
0
It
degree.
should have been 0, means it should actually retrace its path. Logically, right?
Yes, sir.
Right. So this is the incident ray, this is the reflected ray, means they both are on the same line. So, but one ray is obviously not sufficient for me to trace the location. The other ray, what I will do is, I will take the base of the object. So the base of the object, through the base of the object, I'm drawing these lines, imaginary lines. What do I call these imaginary lines as? Can I call it as principal axis?
Oh yeah, principal axis.
But that's wrong. Don't use that word, okay? Again, principal axis is only for curved surfaces. Plane mirror doesn't have anything like principal axis. Because principal axis has a definition. I can draw an imaginary line like this also. I cannot call it as a principal axis. Guys, I'll ask so many questions like this, okay? Please be careful. Okay? So there is no thumb rule. There is no principal axis for whom? For a plane mirror. It is there only for a curved mirror. That is for a concave and a convex. Okay. So I have taken the base as the reference. That's it. From the base, from the top, I am drawing a ray like this. Okay. Now, if I take this as the angle of incidence, if you guys want to know, you can actually use a protractor and see. If I take this as the angle of incidence, then what is the so-called imaginary line with respect to the ray?
Normal.
Normal.
It is a normal. So what does the loss of reflection state?
Angle of
The reflect.
incidence is equal to.
So this angle will be the same. For example, if you're drawing 30 degrees here using a protractor, you draw the same 30 degrees here also. Now tell me one thing. This is one reflected ray. This is one reflected ray. Are these two reflected rays getting converged or diverged? For those who don't know what is converged, converged means moving towards each other. Diverged means moving away from each other. Are they moving towards or away?
Away.
Away from
Away.
each other.
So any two reflected rays, if they move away from each other, will always form a virtual image. What do you do generally? You try to extend the reflected rays in the backward direction. Are you able to understand? This is the reason why the image is formed exactly at the same distance with respect to a plane mirror. Now the textbook sentence makes sense, right? Now you know the answer also.
Yes,
Guys, clear?
Yeah.
Please make a note of it. Now, let's try to write the data for it. If I have to report the image, if I have to report about the image, what are all the details I can give? First, it is a virtual image. Second, about the size of the image. So what is the size? It is
Remains the same.
same size as
Same
that of
size as the object.
the object, right? So with respect to a mirror, if the object and the image have the same size, what is the magnification?
0.
1.
Okay, it is 1.
Sorry.
Magnification means size of the image to the size of the object. When they both are of the same size, answer is 1. It is not 0. 0 means diminished.
Okay.
Okay.
Okay, sir.
So now what we can do is, let's say there is an assertion reason based question asked. The magnification of a plane mirror is always 1. Assertion. Now I'm framing a question. Magnification of plane mirror is always 1. Okay. Reason. The image distance is equal to the object distance. Guys, tell me what is the answer.
Both A and R are true, and R is the correct
R is the
reason.
correct explanation of the
Very
assertion.
good. So R is the correct explanation for assertion. Now the question. Now I'm giving you the reverse analysis. I want you to frame a reason which is wrong explanation for assertion. Don't use the word image distance and object distance. Without using image distance and object distance, you frame a statement for reason which is wrong for the assertion.
Height of object. If the height of the object is equal to the height of the image.
Then also then the
Oh, no.
reason is right for assertion.
I mean, I'm trying to inverse the formula.
Okay. One more thing. What we can do is it forms a virtual image, you can say. Suppose they give you the reason as it forms a virtual image. Does virtual image has something to do with the magnification?
Oh, sir.
Yes.
Okay. So there's a basic, and from this the questions can be framed. Clear, guys? And obviously you know the concept of this lateral inversion. You have been studying since 8th standard. Right? That point
Yes.
I'm giving. Okay. Next. Now we will talk about spherical mirrors. So when I talk about a spherical mirror, obviously we know that it has a concave and a convex surface. Okay. So what are all the parts of this
Center of curvature, pole,
mirror? Okay.
focus.
Okay, what are all these points? If I ask you to give a definition for it, what are you going to say? Let's start with pole.
Pole would be the center point of the reflecting surface.
Is the center point of
Of
the
the-
reflecting surface. Then what is center of curvature?
If the convex mirror or the concave mirror is
Mhm.
full, like a full circle, then the center of the
Okay.
circle would be the center of curvature.
Okay, it's a sphere actually. Okay, because these are called as spherical mirror. You don't use the word
Yes.
circle. Okay, that's right. So what she is trying to say is pole means if this point is A, this point is B. From A to B, there is a distance, right? There is a distance. So exactly the midpoint of the distance is what we call it as a pole. Then what is the center of curvature? Center of curvature is a point. The center of curvature is the center of the sphere from which this mirror is actually taken out. So center of curvature will be somewhere over here. So center of curvature has nothing, will not lie on the mirror, whereas the pole will lie only on the mirror. Okay. If these 2 points are taken into consideration, now how do I define something called as a principal axis?
Line joining the center of curvature and the pole is called as the
Yes,
principal axis.
the line joining the center of
Imaginary
curvature. It's an imaginary line. Okay. The imaginary line that is joining the center of curvature and the pole is what we call it as principal axis. Okay, accepted. So it's applicable for both the mirrors. Next. Then what do I call as a focus? So what exactly does focus mean?
Midpoint of C and P, the center of curvature and the pole.
Is that the way we define?
No,
Then midpoint
it's a
of C
point
and F.
on the principal axis through which, when the light rays coming parallel to the mirror
Parallel
converge.
to? No. Parallel to is right, not mirror.
Parallel to the spherical mirror, reflecting side of spherical.
That's not it. Rays which are parallel to something else.
The principal focus, principal axis converge at the principal focus.
They converge or appear to converge. That's it. Okay. So I want everybody to understand this thing, because I'm asking all these things because the ray diagrams have a reason why we are doing that. Okay. You will understand. You will have a better understanding. So if I take this as the mirror, then this is called as the pole. This is called as the center of curvature. So if any ray is taken parallel to the principal axis, then after reflection, will meet a point on the principal axis, which is called as a principal focus. They generally see, you would have studied it as focal, but some books refer to it as principal focus also. Now I have a question. Okay. So this is where you will understand the importance of normal. Now I have a question. How do you know that the ray is meeting exactly at the principal focus? Because this is an incident ray, right? Again, I'll come back to the same question. If the ray is parallel to principal axis, let's do a reverse analysis. Where is the object placed?
Infinity.
Infinity means it's at a far distance, right? Now this is the point of incidence. I'm still sticking to the only basic that I know till now. That is loss of reflection, because I'm dependent completely on the angles. Now I know the point of incidence. What am I supposed to do at the point of incidence for me to apply the loss of reflection?
Draw a normal.
Draw a normal. So with respect to a plane mirror, I know that normal will be exactly perpendicular to the surface at the point of incidence. But with respect to a spherical mirror, where is a normal? How do I draw the normal? Only geometry should help us. So with respect to a spherical mirror, even without using a protractor or anything, how do I directly draw a normal?
So when we join the point to the center of curvature, it acts as a normal, sir.
Very good. That's right. But can you tell me the reason why it is so? It's there in your
Because joining the center of curvature and a point, it would it would be the radius of the sphere.
That's right. That's right. So yeah, that's right. What you told is right. Now see, normal means a line which is perpendicular to a tangent. So at the point of incidence, I'm drawing a tangent, right? To this tangent, if you draw a line from the center of curvature, you can observe it is exactly perpendicular. Okay. So this is my first incident ray. It is hitting the pole and it is getting reflected in such a way that this angle and this angle are the same. Correct? So
Yes,
this is
sir.
the reflected. Okay, I use this logic to get the reflected. But the ray diagram concept tells me I need another ray to locate the image. Where do I take it? Where is the other ray? I don't have it in my hand. Where is it, guys? Very simple.
It forms at the focus, so
It doesn't.
we do take an
Because what you're doing is you're actually going with the textbook statement. You're blindly believing that it is formed at focus. But I am trying to think, why should it be formed only at the focus? Because I'm sticking to only one thing. I know the laws of reflection. I need two reflected rays to say that this is the point of image. How do I find it? So I have only one ray. I have one incident ray, one reflected ray. I need another other ray, right? So for that, what I can do is I can consider the ray through the principal axis itself, because when I say the rays are coming from infinity, they will be set of parallel rays, out of which I can choose any two incident rays of my choice. Right? So if I take this as the second incident ray, then this is the point of incidence. Okay, I'll take this point as P dash. So in this case, the second point of incidence, the second ray's point of incidence is the pole. Now tell me, guys, I want a keen observation. Tell me what is the angle of incidence of the second ray?
0.
That's right. So the angle of incidence is 0. The reflected ray will start retracing its path. Did you read in this thing? Did you read in the ray diagrams rules that any ray through the center of curvature will retrace its path?
Yes, sir.
So what is the reason for it?
Because both the angle of reflection as well as the incidence are 0.
0. That is the reason. Okay. So I got the second reflected ray. And did I get the point where they are meeting? And you people told me that with respect to a mirror, if both the reflected rays are meeting on the same on the reflecting surface of the mirror, then it is a real image. Then this is what is the focus. That point is what is called as the focus. So at focus, what kind of an image is formed if I have to define its nature?
Extremely diminished, highly
It
diminished.
is highly diminished. It's a real image in the first place. Second is it is highly
Inverted.
diminished. Obviously, all real images are inverted. So it is highly diminished. And it is obviously an inverted. So wherever you see the word real, they are inverted. Virtual images are always erect. Okay. Clear, guys? So this is what we call it principal focus. Anyways, I'll just give you a statement. So the distance from the pole to the focus is what we call it as the focal length. And the distance from the pole to the center of curvature is what we call it as the radius of curvature. Then the focal length of a spherical mirror is half of the radius of curvature. Okay. Okay. Next.
Yes, sir.
Shall I move on?
Yes, sir.
No. Okay. So with respect to a convex mirror, a concave mirror, they actually meet at the principal focus. Whereas with respect to a convex mirror, what will happen? They will the reflected rays appear as if they are coming from the focus, because with respect to a convex mirror, the focus is on the other side. Okay, focus is on the polished side. So here also same thing. F, this distance is R, F is equal to R by 2. Next, the image formation by spherical mirrors. Image formation by spherical mirrors. So what are all the rules that are used? A ray parallel to the principal axis after reflection will pass through the principal focus. Second, a ray through the principal focus after reflection will pass parallel to the principal axis. Third, a ray through the center of curvature will retrace its path. Answer, the angle of incidence is equal to angle of reflection is 0. And what about the fourth one? A ray incident obliquely, oblique means at a particular angle, okay, to the principal axis at point P, then it will reflect back symmetric with respect to the principal axis. Okay, it will make, means the angle of incidence here will be equal to the angle of reflection. Now, keeping all these points in mind, if I have to draw the ray diagram for a concave mirror, then how are we going to do it? So how many ray diagrams do you have, guys?
6.
For concave, you have 6, and for convex, you have
2.
only 2. So totally, there are 8 ray diagrams. So this is pole, focus, the center of curvature. So obviously, you know, when the object is at infinity, you're going to get the image at focus. After infinity, what is the point? It is beyond C.
Beyond.
So when it is beyond C, what will happen? If you take a ray parallel to the principal axis, after reflection should pass through the focus, known point, then what else will be the other ray that you can consider?
The passing through the center of curvature.
You can either take through the center of curvature. So if it is passing through the center of curvature, it will retrace its path. So two rays are enough for us to locate the image. Or else I could have done this also. If I take a ray through the focus, then after reflection, it should have passed parallel to the principal axis. This is another thing. If it is hitting the pole, then it should get reflected back symmetrically. So how many such rays can I think? I can actually think of all the 4 rules applicable to the same diagram, but whichever you are comfortable, you can go with it. Okay, in a way where the image is formed, means all these reflected rays should exactly meet at the same point. If this is AB, then this will be A dash, B dash. Now, what is the nature of this image?
Inverted and real and diminished.
So real and inverted, obviously. Next, it is diminished. So when I say diminished, this is another way. Okay, I can say, you guys know what is magnification, obviously, right? Magnification is less than 1. This is a numerical way to say it is diminished. Why is it less than 1? Because what is the definition of magnification, guys? It is a ratio of something. It is a ratio of the
Height of the image by
height of the image. That is the output by the input. So height of the image divided by height of the object. When I say diminished, height of the image is less than the height of the object. So when you divide a smaller number with a bigger number, the final output will be less than 1. Okay. Next, what will be the ray diagram, guys?
The image lying, the object lying on C.
At C, right? So when I take an incident ray, it will get reflected and pass through the focus. When I take a ray through the focus, see, my diagram is actually not to the scale. That is the problem. Because, so where will the image be formed?
At C.
At C. Okay. I've made some slight adjustments. Okay. So this is what happens. So that is formed at C. So AB, A dash, B dash. Image, nature. Real and
inverted and same size, sir.
Same size. Magnification
Equal to 1.
1.
1. Suppose there is a question. It's a simple question. Okay, let's try to frame it. So there is a concave mirror whose focal length is 5 centimeters. Okay. The object is placed in such a position that its magnification is 1 unit. Sorry, it doesn't have unit. So the magnification is 1. Then what is the object distance? I'm repeating the question. There is a concave mirror whose focal length is 5 centimeters. The object is placed in such a location where its magnification is 1. Find the object distance.
Object distance is equal to the image distance.
That's right. But what is the value?
Did they say that the object is placed on the focus?
So 10 centimeter.
10 centimeters. No? There is nothing to think in that.
Oh yeah.
Because that's it. R is equal to F. No, because the object is placed at the center of curvature.
Yes,
So
I understand.
right? Got it? So 20 centimeters. Sorry, 10 centimeters. Just a slightly twisted question. That's it. Instead of saying using the word center of curvature, I used all these magnification to just create a small confusion. Now I hope everybody is clear. So what I'm trying to say is the object is placed in such a position. So when can the magnification be 1 with respect to a concave mirror? When the image is also formed at the same location. That is possible from the ray diagram chart or table only when the object is placed at center of curvature. Okay. Whereas if the same question is like this, the focal length of a concave mirror is 5 centimeters. Okay. The object is placed at a particular location where the magnification is less than 1. And I ask you the question as find the object distance. What is your answer going to be? I want the exact location of object distance. It's simple. I know you people are thinking so much.
Beyond
Data,
C.
Beyond C, but if I ask you the exact location of object distance, the data is insufficient, right? Because that is not enough for me. So beyond C is right. But when I say object distance, I want the exact value. When I want the exact value, it cannot find. Okay, don't worry, these kind of questions don't come. It is just to improve your thought process. Okay. So what is the next one? No? At C is over, then?
Between C and F.
C and F.
So between C and F, where is the image formed?
Beyond C.
So what are all the rays that you're going to consider? A ray parallel to the principal axis reflects through the focus. A ray hitting the pole will reflect back symmetrically. Again, a mistake in my diagram because look at the angles. 1 minute. Let's take it like this. It should be formed beyond C. So A, B, A dash, B dash. Now tell me about image, real and inverted, same story. Then
Enlarged.
enlarged. Okay. Magnification.
More than
More
one.
than 1.
That's right. It's greater than 1. Okay. Next. At focus. Where is the image formed?
At infinity.
So ray parallel. Okay, I cannot take this. Then how can I draw the ray diagram for it? I can think of a ray which is appearing to pass from the center of curvature. So if I take a ray like this, the incident ray will also be in this way. The other ray, I can think of the pole and something. Sorry. I can think of hitting at the pole and something like this in such a way that these two rays will be parallel to each other. Then you will have nothing. So these two rays are definitely. So when are these two reflected rays? Where are these two reflected rays which are parallel to each other going to meet? They'll meet at infinity. So
At
you will have
infinity.
real and inverted. Okay, don't make a mistake of writing it as virtual. They are not getting diverged. They will meet at infinity, but we don't know where that infinity is. So real and inverted, then
Highly enlarged.
it is highly enlarged because its magnification is almost like infinity. Next, I can write M as infinity.
Magnification is more than 1.
It is very much greater than 1. That's what we. Anyways, this point you don't need it. So when I put double arrow, double greater than symbol, no, you read it as magnification is very much greater than 1 or greater than something. Okay. Next is between F and P, between the focus and the pole. So where will the image be formed?
Beyond the
The
mirror.
virtual image.
Behind the.
Yeah.
Behind the mirror, because they get diverged. So this is the point where a converging mirror actually starts behaving like a diverging mirror.
Diverging mirror.
Nature.
The
Virtual
Virtual,
and
erect, enlarged.
virtual images are always erect in nature. Enlarged,
the magnification more than
greater than 1. That's it. Okay. So same thing you can do with respect to a convex also. Let's see that. So what are all the uses of concave mirrors? They're commonly used in torches, searchlights, and vehicle headlights to get powerful parallel beams of light. Okay, they're often used as shaving mirrors to see a larger image of the face. So for them to act as a shaving mirror, where should your face be? I'm not sure if you guys have seen it.
between F and P.
It should be between the focus and the pole. Okay. Similarly, the dentists also use concave mirrors to see large images of the teeth of patients. Okay. Large concave mirrors are also used to concentrate sunlight to produce heat in solar furnaces. So these are all the uses of concave mirrors. Next is about the images formed by a convex mirror. So with respect to a convex mirror, same logic again, but only the difference is here you don't have beyond C and between C and all those things. Only two things. One is at infinity. Second is somewhere close to the mirror or somewhere between infinity and the mirror. That's it. So when it is at infinity, obviously the virtual image is formed at the focus. When it is placed between infinity and pole, where is the image formed? It is formed between the pole and the focus. It is exactly the reverse of what happens in a concave mirror. Right? Guys, I hope you know how to draw these diagrams. Right?
Yes, sir.
Yeah. So at infinity, you can tell me the nature, no? Position of the images at focus, size of the images highly diminished and point size. Yeah, it is obviously virtual. So when I use the word, you will have a doubt how to say whether virtual and inverted or virtual and erect. If you use the word virtual, by default erect, because here it is point sized. For a point, see, inverted means arrow mark is downward, erect means arrow mark is upward. But for a point, how are you going to draw arrow mark? So who is deciding whether it is real or inverted or erect? It is a word virtual or real. Virtual always erect, real always inverted. Okay. Next. Similarly, the image is formed between the pole and the focus behind the mirror. It is diminished. It is not highly diminished. It's the same thing. Virtual and erect. I hope that makes sense. So now you guys will be able to define what is the principal focus. Principal focus and the focus mean the same. What are they? When a ray is taken parallel to the principal axis, the rays converge or appear to converge at a point on the principal axis called as the principal focus. But here they have asked about the principal focus of a concave mirror. So for concave mirror means they will get converged. Converge means coming towards each other. So what is the other name for concave mirror? It is called as converging mirror. Whereas a convex mirror is a diverging mirror. Next. The radius of curvature of a spherical mirror is 20. What is the focal length? It is
40.
10 centimeters. The radius of curvature 20.
Okay, sir.
Focal length is 10. Okay. They use the word spherical mirror. Okay. Now, I want to slightly twist the question. I want to make that spherical mirror as a concave mirror. What will be the answer?
Minus 10 centimeters.
Yes, that is what I wanted to check. So, focal length of a concave mirror is negative. So, please ensure you're writing the correct answer. It is minus 10 centimeters. Had it been a convex, it is plus 10. So, name a mirror that can give an erect and enlarged image of an object. So, if you observe a convex mirror always gives you a virtual image, but it is always diminished. But is there a possibility for you to have a virtual and enlarged image? Yes.
Concave.
For a
Concave.
concave mirror, when the
Between
object
F
is
and
placed
T.
between the F and T. Yes. Why do we prefer convex mirror as a rear view mirror in vehicles? Logically. So vehicles are big in size.
Provides small images, diminished images,
Exactly.
and wider views.
Exactly. So since convex mirrors always form a diminished image, we use them and they give you a wider view. That's right. Right. So sign convention, with that we'll stop. So sign conventions for reflection by spherical mirrors. So if I take this point as the pole, okay. So how I generally take this while solving the problems, I draw an imaginary axis like this. I take the pole as the origin. Any distance measured on the left of the mirror is negative. Any distance measured on the right of the mirror is positive. Any distance measured above the principal axis is positive. Any distance measured below the principal axis is negative. Okay. So you can have, see, I have a question. Why is it always like this? If I take something like this, what kind of a mirror is this?
Concave.
It is still a concave mirror, right? If I take this as the origin, okay, if I take this as the origin, then I'm going according to the quadrants concept. This is the first, second, third, and fourth quadrant. So first quadrant, both x and y are positive. Second quadrant, x is negative, y is positive. Third quadrant, x and y both are negative. Fourth quadrant, x is positive, y is negative. If that is the case, I can take this side as positive, this side as negative. This is positive, and this is negative. While solving a problem, what difference do you think will happen between this and this?
So here the object is placed in the negative side, and there the object
Yes.
is placed in the positive side.
Placed in the positive side. So, with respect to the problem solving techniques that is universally followed, I'm not saying it is wrong. With respect to the problem solving technique that is generally followed, the object distance is always taken as negative. So, when I say object distance is taken as negative, you always need to ensure that your polished surface is always in the left hand side. Sorry. The reflecting surface is always on the left hand side. The same logic is applicable with respect to a convex also. You need to ensure that the object is always kept on the left hand side. Is that clear? So that is one important point to be kept in your mind. So next class, what I will do is I will start with the problems. I'm sure you guys would be confident with the problems also, but still let me do some problems so that if you get a different perspective, you can take it. Okay. Any other doubt from today's class?
No doubts, sir.
Shall we wind up then?